Understanding Elastic Collisions and Conservations of Momentum by Hyson Dib. Contents. Welcome. Today we're diving into the fascinating world of elastic collisions and how they tie into the fundamental concepts of momentum conservations. What is an elastic collision? Elastic collisions are collisions where both kinetic energy and momentum are conserved, and this means that after the collision, the total kinetic energy remains unchanged. Imagine two perfect bouncy balls colliding and bouncing off each other without losing any speed. Now, example in real life. Elastic collisions are rare, but a good example can be seen in a game of billiards. When two balls collide, their kinetic energy and the momentum are nearly conserved. Conservation of momentum. Momentum is defined as the product of an object, mass, velocity. The law of conservation momentum states that total momentum of a closed system remains constant as long as no external force are acting on it. Example. For instance, when two cars are colliding in an accident, the total momentum before the collide is equal to the total momentum after, assuming no external forces like friction are involved. Mathematical representation. The equation for momentum is P equals mv, where P is momentum, m is mass, and v is velocity. In an elastic collision, the equation holds true for both objects involved. Formula for conservation: m1 v1 plus m2 v2 equals m1 v1 plus m2 v2, where m1 and m2 are masses and v1 and v2 are initial velocity, and v1 and v2 are velocities after the collision. Example of elastic collision in action. Let's look at a practical example. Imagine two carts on a frictionless track with one stationary and the other one moving towards it. When the moving cart collides with the stationary cart, the momentum and energy are transferred from the moving cart to the stationary one. Visual aid. Here's the moving car slowly down while the static car speeds up. So just imagine one stationary cart and one static cart, and the static cart is moving faster, stays here, and it goes hits it like that. Real world applications. Where can we use this in the real world, you may be wondering? Elastic collisions may be rare in everyday life, but they still appear in certain fields and practices in physics practically often undergo elastic collisions and acceleration. They're also a key in the study of gases, where molecules collide excitantly in a closed system. Examples in real life. An airbag, through collision, aren't perfectly elastic. The principle of momentum conservation still applies in designing how airbags deployed to reduce the impact forces. Why does momentum conservation matter? Conservation matter. Understanding momentum conservation is essential because it helps us predict the outcome of collisions, which is crucial in fields ranging from car crash analysis to understanding atomic and subatomic partial behavior. Now let's look at an example. Engineers use these principles to design a safer vehicle, ensuring that the energy transfers in a collision is optimized to protect the occupants. So when they're making a car, they make sure that the car will evenly spread out the impact radius and will eat up a lot of impact, so the person in the car will not take a lot of impact and the car is safe. So when you hit a car, the impact goes in, and they want to make so it stops the impact and not so the impact goes through. It stops right there instead of going through. Conclusion. In summary, elastic collisions show the beauty of physics where energy and momentum remain conserved. Whether we're studying particle accelerators, or the design of safer vehicles, the principle of momentum conservation help us understand and predict real world phenomena. Thank you for listening to my presentation on understanding elastic collisions and conservations of momentum. Have a great day.